You may have already heard of PASCO's code.Node. This compact device houses multiple sensors and gives the user the ability to program several outputs, such as the RGB LED, speaker, and 5x5 LED array. Now you can add additional measurements, such as position and velocity, using the code.Node cart. The code.Node cart is an accessory that is used along with the code.Node to expand on programming and even reinforce physical science concepts. We just need to insert our code.Node into our cart. The construction of the cart allows for one to tie a string in front, insert a light spring, or even house weights to increase the mass of the vehicle. The cart with the code.Node works in both our SparkView and Capstone software applications. The introduction of the code.Node cart gives the user the ability to determine cart position as well as cart velocity. The code.Node cart records cart position and cart velocity data by monitoring the axle magnet on the code.Node cart. As mentioned before, the code.Node cart can be used to reinforce physical science applications along with coding. Velocity is speed in a given direction. With the code.Node, the cart is able to determine its velocity. To reinforce this concept, students can program the device to display a visual vector on the 5x5 LED array on the code.Node as the cart is in motion. For this demonstration, we'll be using SparkView. All right, so I'm going to click on Sensor Data, and I want to draw your attention here. Those of you that are aware of the code.Node probably see a lot of sensors that you've seen previously, but now we have the addition of cart position and cart velocity. For this demonstration, I'm going to use cart velocity and disable these other sensors and bring up this graph. So you're going to notice when I hit start and move the cart forward, I have a positive velocity. When I move the cart backwards in reverse, I have a negative velocity. This is important because we're going to use this data in our coding program. I'm going to click on the code icon and let's get building. All right, so I'm going to pull in a loop, and this basically is telling the program I want it to run over and over again until I hit stop. And then I'm going to bring in 2 logic blocks. The hardware you're going to be utilizing in this program, you choose this first one, and you're going to see it says brightness right now, but when you click that, it gives me the ability to choose cart velocity. So when the cart's velocity is positive, greater than 0, I want it to give me a forward arrow. So again, under hardware, I can pull up this LED array programmer, which is really nice because I can choose which LEDs I want to illuminate quite quickly. And that's going to be my forward arrow. And now you can either pull more blocks or you can duplicate, which makes it a little bit quicker. I'm going to say when the cart's velocity is less than 0, I want the arrow to go the other way. It's going to be a backwards arrow. Almost there. All right, quick run through. If the velocity of the cart is greater than 0, I'm going to have a forward arrow. If the cart velocity is less than 0 and negative, I'm going to have a backwards arrow. All right, I'm going to pull back up my graph display. All right, so if my code is correct, when I move the cart forward, you're going to see a positive arrow. When I move it in reverse or backwards, you're going to see negative, backwards arrow. And success. I move in reverse, negative velocity, I have a backwards arrow. Move forward, positive. That's just one of the many concepts you can model with students. You will find the code.Node cart is a valuable addition to the code.Node. Access to activities that utilize a code.Node cart can be found in our Teacher Resource Center at PASCO.com.